Okay, this is looking at using logs to solve different kinds of equations. So we have three different forms of equations we're going to be looking at here. First form is where we have x in the exponent. Another form is where you actually have a log as part of the equation. The third form is where you have x raised to a power. So we want to look at each one of these because each one takes a different kind of a technique. So let's look at type 1. Logs needed to solve, so we need to use logs to be able to solve the problem. So the basic rule we're going to use is this one. Log of a to the x is equal to x times log of a. That's the main rule we need to use when we have this kind of a problem. So the typical one, and this may have occurred after simplifying and doing some other work, but I've got a number raised to the x equals another number. What we're going to do is apply this rule here again to solve it. So I'm going to take the log of both sides. Next, you can use any base, but we generally use base 10 because that's what our calculator has. So I got log of 5x equals log of 108. I'm going to apply this rule right now, and I could take this x that's right here, and I'm going to move it to the front. So I got x log 5 is equal to log 108. Now my advice is don't calculate out what these are yet. Wait, do the division, and now you punch this into your calculator. Do log of 108 divided by log of 5. And the result is about 2.91. So we're going to look at another example now. So this was the original one that we showed on the original examples. So we need to isolate this part of the equation. So think of this as 5,000 times A plus 10,000 equals 100,000. Well, first I'm going to solve for this part. So I subtract 10,000, divide by 5,000, and now this problem is the same as that one in terms of steps. So I'm going to take the log of both sides, and we can skip this first step because we know what we're going to do. We're going to move x out in front, and then divide log of 18 divided by log of 1.06, and we get 49.604. Okay, let's look at one more example. Let's say we had 20 times 3 raised to 2x minus 1 minus 80. Again, I want to isolate the part that's raised to the x. So it's like having 20a minus 80 equals 10. So we add 80, divide by 20. Now I'm ready to use logs. Now when I use logs, the 2x minus 1 is like having parentheses around it. So I take 2x minus 1, it's going to come out in front when I take the log. Then I'm going to take log of 4.5 divided by log of 3. Now I can evaluate this in the calculator and now solve it like normal. Add 1, and then divide by 2. Okay, that's your first type of problem. And basically, it comes down to when you have x in the exponent, or the variable you're trying to solve for is an exponent. Remember, logs are exponents, and that's kind of important to realize. We use logs to solve for exponents. Logs are the inverse of an exponential equation. Second type is when you have log action in the equation. And to do these kinds of problems, we're going to take our log properties and convert it to an exponential. So log base b of a equals x. Logs are exponentials, so that means log equals the exponential, or the exponent. So b raised to the x is equal to a. So, for example, I'm going to change this around now. So 4 raised to the second power is going to equal 2x minus 3. Well, 4 squared equals 16. Add 3, I get 19. Divide by 2. Another example. This time we have x plus 4 as the base. So x plus 4 raised to the third equals 7. To undo a cube, we take the cube root. Again, I could do this part of my calculator. And then I'll subtract 4. Okay, so let's take a look at the third type of equation. Oh, one more example. Let's say we have log 1.7 of 25 equals x. Again, use the same rule. So my base is 1.7 raised to the x equals 25. And now it becomes like the very first problem we did. So I have x log 1.7 equals log of 25. We take log of 25 divided by log of 1.7, and we get 6.066. Okay, type 3. I've got to change type. Well, no, still another example. Forgot about this one. Oh, original example. I never did our original. Okay, so here's our original. So it's 3 to the fourth is equal to 2x minus 5. We're going to add 5, then divide by 2. Okay, finally, now type 3. This one is kind of misleading because log is not needed anywhere in the problem. But you have to know when to use log, and that's the key. So you just can't say, oh, I'll use log on everything. No, you got to know when to use log. We use logs to solve for an exponent, not to get rid of an exponent. That's different. Here, I need to get rid of the exponent. To get rid of an exponent, we take the root or we raise to the reciprocal. So if I take 8 raised to the 1/8, 8 times 1/8 is 1. 50 to the 1/8, I simply type in my calculator. Okay, let's look at the other problem we had. This is the last one we did have. So again, I'm going to isolate this part. So it's like having 25a plus 18 equals 268. So we'll subtract 18, divide by 25. Now, to get rid of the raised to the 3/4 power, I'm going to raise both sides to 4/3. When I raise 4/3 on the left-hand side, 3/4 times 4/3 means I got x minus 10 to the first. 10 to the 4/3 is 21.544, which makes sense, a little bit more than 1, so it's going to be greater than 10 but less than 100. Then add 10, and I got 31.544.